Hello, I'm Lynn, and this webinar is going to cover a little bit around level 2 math skills that you'll need to do formula questions. So those are the kind of questions that you'll see that will look a bit like algebra, and they tend to scare people off a bit. So we'll be looking at some techniques you can use to tackle this a bit more easily, some of the top tricks, and then we'll be going through some example questions. So we're going to go straight into look at the objectives, and then we'll look at some sample questions.
So we're going to be looking at formula and BODMAS, which some of you may know as BIDMAS, and that is actually part of doing the formula calculations. So I just want to make sure that everyone's confident with both aspects. So if we look at our objectives, we'll be looking at some of the uses of formula. We'll be looking at what BODMAS actually means and how to use it. We're looking at the layout of some of the formula questions and how to set them out yourself. And then we'll be looking at doing some practice questions and some example exam questions that involve formula. One of the things I find when we're doing formula questions is that people say, it's algebra, I hated algebra at school, never understood it. As soon as they see a formula question, they just whiz by because they just hate those type of questions. And actually all it is having a set way of working something out where you can change some of the values or numbers depending upon what you're doing. So actually algebra and formula are just a way to make something simpler. One of the most common ones, which many people will have used or will use in their career, is actually working out mileage claims. So it is quite a useful skill to have to make sure you're getting paid enough in your job. But there's lots of other formulas that we perhaps do use regularly, but we just don't recognise them as being either formulas or algebra, as I said. So we'll look at what BODMAS is, and some people call it BIDMAS. It really doesn't matter, whichever one you prefer, stick with it. If we go with BODMAS to start with, the B stands for brackets, the O for order. If you're using I instead of the O, then that stands for indices, D for divide, M for multiply, A for add, and S for subtract. And what it actually is, it helps you to understand the order that you should do your calculations in. So any calculation should follow the order of BODMAS or BIDMAS. So you look to see if there are any brackets there first, and anything that's inside a bracket you should always do at the beginning. Then the order or over or indices, that's the slightly confusing one. Indices is maybe a little clearer because if you have something that's squared or cubed, then that should be done next. Now the next four sometimes confuse people because they take it very rigidly that they must be done in that order. And in fact, divide and multiply are equal because it doesn't actually matter what order you do those in. And add and subtract in some ways are equal, but if you're unsure, follow the order that they're written down in the question. So if you're not sure when to do add and subtract, just follow the order of the question. But the important thing is that any adding and subtracting must be done after any dividing or multiplying. So as I said, BODMAS is important to make sure that you are working out your formula in the right order. If you do them in the wrong order, then generally the answer won't be correct at the end. So whenever you're doing these questions, always make sure that you're following BIDMAS or BODMAS as you go through. So if we look at some very simple ones to start with, just have a think about how you would work these out. And as with the other presentations in our series, it's a good idea to pause when there's a question, have a go at working out yourself first, and then play the video again and you can see how you got on with your answer. Now, some of these early ones might be a good opportunity to practice using your mental maths or your paper maths rather than your calculators, but that is up to you. Some of the later questions might be a little bit tricky without a calculator, so I would suggest you have a calculator to hand for some of those, and of course a piece of scrap paper and a pen. If you haven't got those ready, pause now, go and grab them, come back and have a go at these two questions. So the two questions there, the difference obviously is where the brackets are in the first one but not in the second one, and that will change the answer, so you will get two different answers. If you want a bit more time, do pause. Otherwise, we'll look at how to work those out. So in the first one, you have to do the part in the brackets first. So the 6 and the 4 need to be added together to make 10, and then they're multiplied by 2. So the top one will give you the answer of 20. In the second one, there's no brackets, so we follow the BODMAS order of doing the M of multiply before the A of add. So we multiply the 2 and the 6 together to get 12, then we add 4 on, so our final answer would be 16. So always make sure you're doing your brackets first, and then if no brackets, follow the order of BODMAS, doing the multiplying before the adding. Couple more questions again for you to try. Pause here and take as long as you need, and then we'll have a look on the next slide at how to work these out. A little bit different, these two, so it'd be interesting to see what answers you get. Now in the top example, the 10 divided by 2 has to be done before the addition, so we'll do the divide before the adding. So 10 divided by 2 will give us 5, then we add the 3 on to give us the final answer of 8. Now the second one is a little bit sneaky, because although there's no brackets, by having the 10 plus 3 on top of a fraction, that means that part has to be considered as one unit. So effectively, there are brackets there, they're just not written in, they're assumed brackets, which some people find a little bit silly, but that's just how it works. So if you see some parts on top of a fraction or on top of a division, you do those as if they're in brackets. So in this case, we add the 10 and the 3 together first to give us 13, and then we divide by the 2 to give us 6.5. So again, completely different answers. Also, just to be aware of different ways of showing division. So here we're using division at the front like a fraction, which is showing the division. At the end of that question, I've shown division using the slashed line where I've put 13 divided by 2. And of course, there's also the traditional division symbol. So do make sure that you're comfortable seeing all three of those ways as a way to do a division question. So that's just an example of how BODMAS can change an answer depending on the order. And there is one set order to do things in. So you don't need to guess, you just follow that set order. Couple more to try now. Have a go at these. As I say, pause and then carry on when you're ready. So here's the top one. So we're starting off by following our BODMAS or BIDMAS. The brackets has to be done first. So if we look inside the brackets, the 6 plus 2 has become the 8 in the second line. Now we complete the multiplication part of the top of the fraction, which is 5 times 8. Now I didn't really need to put the brackets around the 8, but I just left it there so you could see how the bracket from the top changed. So we must do that part next. 5 times 8 gives us 40. So we're now left with 9 minus 40 on the top. We then finish that part off as if there are brackets on the top of that fraction, those assumed brackets. Now this is something you do need to be careful of, because we're doing 9 minus 40, we're going to have a negative answer. Always be careful, especially if you're using a calculator, it can be easy to miss the minus sign. So do always use common sense to make sure you put those negative symbols in where they're needed. So the top of our fraction is now minus 31. And we've finished that top part, so now we can go back to looking at BODMAS. We've done our brackets, we've done all the other parts, it's divide next. The only two things we've got left are a division and an addition. So we do the divide, minus 31 divided by 2, which gives us minus 15.5. And then finally we do the addition, which is minus 8.5. So well done if you got that as your final answer. Of course, when you're watching these videos, it is also fun to fast forward. So if you've got an answer right and you're really confident with it, you can fast forward through my explanation, so you can get on to some of the harder questions later. That is absolutely fine. Now we'll look at the second question we did. A little bit more straightforward. 100 minus 5 divided by 2. Because of BIDMAS, we do the division first. So the 5 divided by 2 should be done first. So half of 5, 2.5. we now have 100 minus 2.5. We do that subtraction and we get 97.5 as our final answer. So of course those people that did 100 take away 5 first to get 95 and then halved it would get a completely different answer. So do of course always make sure you're following BODMAS or BIDMAS when you do any kind of calculation. I mentioned indices earlier as being the I if you're using it as BIDMAS. So you do just need to be aware of what squared and cubed look like. They tend to be the main indices that you would come across. So just a quick recap, 8 squared means 8 times 8. So 8 squared is 64. It doesn't mean 8 times 2, which some people get mixed up with. If you're using it more algebraically, a cubed means a times a times a, not 3 times a. So that's very different. So if you had a cubed and you were told that the value of a was 5, then that would be 5 times 5 times 5, which would come out at 125, not 3 times 5, which of course would be 15. So do always check those indices. Do just be aware of doing them incorrectly. And then some of the layout questions again, just to be aware of how things look really. There's a couple of rules for algebra that you do need to know. The main one is that generally in algebra they do not use the multiplication sign, so the times symbol isn't used. And the reason I think that is because it can be confused with the letter X, which of course we all know is used all the time in algebra. So the letter X is used to represent a value, but the X as in the times symbol is not used. And the rule I was taught and I always remember is when things touch, they times. So when letters and letters are touching or they're together in the question, it means that they multiply. It's just the multiplication symbol isn't there. So if we look in the middle of our screen, we've got 12 and then bracket 5 minus 2. So that means the 12 is touching the brackets, so it multiplies by everything inside that bracket. If we put the times symbol in, it would look like 12 times 5 minus 2. So of course, if we actually did that calculation, we'd do the 5 minus 2 first, which will of course give us 3, and then we'd multiply 12 by 3 to give us 36. If you see something like 6a, that means 6 times a, or 6 times the value of a. So if a was 4, then we would replace that with 6 times 4, which would be 24. And again, you're still following the rules of BODMAS. So I just want to take a look at this question just to explain how algebra and use of letters can simplify something that can look very complicated or long written out in full. So this example is around driving. A driver is paid £20 per hour and gets £50 per day for expenses. So here's a formula you could use to work out his pay, quite straightforward. 20 times the number of hours plus 50 times the number of days, which is fine, but it is quite lengthy. So we'll see in a moment how we could simplify that. So what we could do is write that much more simply. Rather than using all the words, we can write 20 times n to stand for number of days, and 50 times d, sorry, the first one stands for number of hours, and the second one 50 times d to stand for the number of days. If we follow our rule about not using the times symbol, we just take that out. So we'll have 20n plus 50d. And of course, we now understand that that means 20 times n. Just because we can't see the symbol, we know it must be there because the 20 and the n are together or they're touching. So if we use our formula and we have some information, so in 1 week, he works 35 hours over 4 days. So we want to know what his pay would be. And if you'd like to pause here, you can take your time to work that out. Again, you might want to try doing it without the calculator if you like, and then resume when you want to see the answer. So I've replaced the number of hours with 35, and I've replaced the number of days with 4. So the first thing I'll do is 20 times 35, and that will give me 700. A quick way of doing that, if you want to do it in your head, 2 times 35 would be 70, and then add that naught on the end. 50 times 4 days, 5 4s are 20, add the 0 on the end. So we've got 700 plus 200 equals 900. So our final answer, the driver earns £900. We'd always put the pound symbol on when we present the answer, because you never know in the exam which questions require the correct units. So it's always very good practice to put the units on, and then you can never lose the mark for doing that. We're going to look at another example now. So in this question, it's 4 machine workers at a factory earn £6.89 per hour, and 6 administrators at the factory each earn £7.25 per hour. They all work a standard 37 hours in a week. Which calculation would show the total pay for 1 week? So again, I'd suggest that you pause here so you can have a go at this question yourself, and then resume when you're ready. So if we take a look at what's actually happening in all of these calculations, the very top one, let's put A or the first one, they are multiplying the people by the hours correctly, but they haven't taken into account the 37 hours anywhere, so that wouldn't be correct. If we take a look at the second one, now this is the one that actually is the correct one, because what they're doing is multiplying the workers by the hours correctly, and then multiplying all of that by 37. Now some people might be puzzled because they think, well, they've got all of it in one go in the middle. How do you know about the order? But of course we'll use our BODMAS. So you would do the 4 times 6.89 first, then the 7.25 times 6, and then you would add those two numbers together. So you would never add the 4 and the 7.25 together first. That would be incorrect. If we look at the third option down, unfortunately what's happening here is that the 37 is only being multiplied by the last part of that formula. If we follow our BODMAS, we'd do 6.89 times 4 first, then we would do 7.25 times 6 times 37 as either one calculation or two, whichever you preferred, and then that answer would be added to the answer of 6.89 times 4. And that means that first part, those 4 workers, their hours wouldn't have been multiplied by 37. Looking at the final example, a similar thing is happening but in a different order. So here the bit in brackets would be done first, the 6.89 times 4, then that would be multiplied by the 37, then the 7.25 would be multiplied by 6, and then those two parts would be added together. So again, the hours for the 6 workers would not have been multiplied by the 37. So you can see just by putting brackets in and changing the order around, you can actually get a completely different answer. So just to remind you, it's the second option that is the correct one. I've mentioned units earlier, so do always make sure you're aware of the units a formula uses. Usually there's some kind of key or bit of information that goes with a question. My top tip is to make sure all your units match all the way through. So if you've got everything in pounds, that's fine. If you've got a mixture of pounds and pence, you may need to convert one of them either at the beginning or the end. So things like grams and kilograms, meters and centimeters. So make sure you're working with consistent units, because they could give you in the question, tell you the measurement is 200 centimeters, but the formula requires you to put the number in meters, and so you would just put it in as 2. And if you didn't read that carefully, you'd end up with a massive answer that was far too big. So do just take your time to check units, and as I said, do present the correct units at the end of a question. Here's an example of doing a question with some units in, and this is where it could get a little bit complicated. So if you want to pause and have a go at this question, please do. So a gas bill is £15.23 per month plus 8p per unit used. If 540 units are used, what calculation would find the total cost that month? And here are those 4 calculations for you to choose from. So if you want to have a go, do pause now. This is quite a good example of a question that has what we would call a fixed amount and a variable amount. So the £15.23 is fixed because that happens each time. The 8p is a variable because the amount will alter depending on the number of units used. So more units used will be a greater cost. So let's have a look at these options, see if we can work out which one we need. What I always say to look for is if there's a fixed cost, that should always be added on, and that should always be added after the other calculation has been done. So we'll have a look and see what order all these things are done in. See if we can discount any. Now immediately I'm looking at the third calculation down, 540 plus 15.23 times 0.08. And I'm immediately going to eliminate that one because we're multiplying the fixed price by the 8, and that just doesn't seem correct, so I'm going to get rid of that. Something else I'm noticing, some of them use 8, some use 0.08 and some use 0.8. So that's something we need to think about, which one of those is correct. Going back to the question, the 15.23 is written in pounds, and that stays the same through all the calculations. So that means if that's in pounds, our 8p needs to be represented in pounds as well. To do that, we'll convert it by dividing by 100 if you want to actually do the conversion, or you may just know already that that would be 0.08. Again, some people forget to put the extra naught in, and they're the people that would be looking at B as an option rather than A or C. So now we know it's got to be either A or C. We've already discounted C. C wasn't correct. So let's just check A works. 540 is the number of units, times by the cost per unit, 8p. You do that first. So actually the brackets in this case are quite irrelevant because with BODMAS we would automatically do that first anyway. But the brackets just make it a bit easier to follow. And then we'll add the fixed price on afterwards. So that's why that one is correct. The bottom one uses the correct method, but hasn't written the 0.08 correctly. So that would be giving you a very large gas bill because you're working there with 8 representing £8 per unit used instead of 8p. So those are some of the sort of tricky, sneaky things you need to watch out for in these sort of questions. Pi is something else you need to be aware of. It's another thing that people are a bit scared of in maths, usually from a bad experience at school at working with pi. So pi has the symbol that you can see on the screen there. Sometimes it looks slightly different depending on fonts, but it will look a little bit like some people call it something with a hat on or funny lines, but it is pi, and normally it's used in calculations that will involve circles. Now, depending on what the question says, sometimes it will tell you to use a rounded value of pi, so it might tell you to use 3, or 3.14, or 3.1, or it will suggest using the pi button on the calculator. If there's no guidance, do make sure you write down as part of your working out what value of pi you've actually used, so the examiner can follow your working out through. Always make sure you follow the instructions in the question, and remember if the pi symbol touches another letter or number, then it means you should multiply it. So if you see 4 pi, that means 4 times the value of pi. So either 4 times 3 or 4 times 3.14 or 4 times the pi button on your calculator. So now we're actually going to have a go at some exam style questions. I definitely recommend that you pause and have a go at these yourselves. I think this question would also be one you could do without a calculator if you want to try that. So make sure you do answer the final question. Can she afford an advert with 20 words? Okay, so we're going to have a look at the answer now. So the first thing I normally do when I'm doing these questions is I take the formula and I write the formula down again and I fill in any letters that I know the value of. So in this case, we've got W as part of the question. W is the number of words in the advert. Now the question says, can she afford an advert with 20 words? So I'm going to replace the W with 20 for my working out. So I now have 12 plus 1.5 times 20. Because of BODMAS, I need to do that multiplication first. So 1.5 times 20 gives me the answer of 30. Then I add that to the 12, which gives me the answer of 42. So that means the advert with 20 words would cost £42. I must answer the question, can she afford an advert? Yes, she can. If you don't put the yes, she can, even if you state the £42, you won't get the full 3 marks because you haven't answered the question. Now there is an alternative way to work that one out, which you may have done. And we're actually going to look at that a little bit later when we look at doing questions in a different order. So if you got the answer right, don't worry, you probably will get the full 3 marks, and we'll see another version of it a little later on. So another question to have a go at now. This one's around a horse, a nice picture of a horse there. And because of the language skills in this question, they point out what girth is, because they use the word girth, and that isn't a familiar word to everybody. And you always have to make sure in these kind of questions that it's accessible to people in terms of the English. They have explained what that means. And you can see here where you've got the W, the G and the B in the middle. It's like the key. It's telling you what each of those represents and the units it represents as well. So I'll let you have a read through that question, have a go yourself, and then on the next slide we'll look at the answer. Now this is one of those questions where people will see that formula with the squared and the b, get really panicky and just miss it out. But actually it's a quite straightforward question. So as I've always advised you, do check your units all match. In this case they do, but you might come across an example where they don't, so I would always do that first. So we've got kilograms and centimetres in our table, and then underneath with the bullet points we've got centimetres, so that matches, so we've got no need to panic about the units. The next thing I always do is substitute any numbers for letters that we're given. So W equals, we know G, the girth of the horse, is 185. So instead of G, I've put 185, and the squared is still relevant. We need to keep the squared. Times B. B is the body length of the horse, which is 160. So that goes on the top. On the bottom of that fraction or that division, the number stays the same. We haven't changed that. Now I do that calculation. Because of BODMAS, I'll do the squared bit first. So 185 squared. So that's definitely one you'd want a calculator for. So that's 185 times 185, which is 34,225. Continuing to follow BODMAS, we then multiply that by 160. And that gives us a rather large number, just over 5 million, 5,476,000. And of course the number on the bottom of our fraction hasn't changed. The last thing we do is the division, so we'll divide that massive number by the 11877. And that gives us 461.05919. And I've written that out in full at that point. You might decide to round at any stage at that last calculation. I'd never round before that point, but at this stage I would apply sensible rounding. Because it's quite a large number, I've just rounded it to the nearest whole number, which would be 461 kilograms. It didn't ask us to round to any units, so you could have said 461.1 or 461.06. All of those would be very sensible. And do put those units on the end, the kilograms, because you never know when those marks would be needed. So actually it looks quite a long question, but as long as you've got your calculator, all it really is just inputting numbers into the calculator. Because they're quite lengthy numbers, I'd always do that twice, just to make sure you haven't accidentally mashed the button next to the one you were aiming for on your calculator and gone a bit wrong, because quite a straightforward question, you don't want to lose easy marks. So I'd always do it once and then just go back and do it one more time. Another question here, quite straightforward I think again. around estate agents' fees. Sometimes the formula questions, you're doing two lots of formulas and comparing what they are. So I'll let you have a read and have a go at this 3-mark question. On the next slide, we'll go through the answers. So we'll start off, we'll look first at all the units. So we've got pounds, pounds, everything's in pounds, nothing's in pence, so that's all fine. Then take one formula at a time and substitute in that monthly rent. So the first one for A is 500 plus 0.96 times R. Now R is the rent, which is 650. So because of BODMAS, we'll do 0.96 times 650 first. And then we'll add that answer to the 500. So remember, you must do this in the correct order. And that gives us 1,124. The second one's even easier because there's only one calculation to do, which is 0.6 times that monthly rent times 650, which gives us 390. So we've got our two figures. I've presented them here using the pound sign. And then I've done my comparison. I've said service A is more expensive, and I've given a reason because it includes full management. So quite straightforward, that one. Nothing really to trap you other than not following BODMAS when you do that first calculation. Another one we can try here. Again, 3 marks. Make sure you answer the question. Do pause and have a go at working it out. So let's take a look at the answer. Again, you may work these out in a different way. As long as you're getting the answers right, you don't have to follow the exact same methods I'm using. Now, in this case, the units will be important because in the sentence it talks about £10. In the box it talks about pence. The kilometres matches, so we don't need to worry about that. In this case, I'll probably do the conversion to pounds after I've finished, but you could do it as you go along. That is completely up to you. So I'm going to substitute in my numbers. So instead of D, I'm going to put 18. And something you might want to check, some of these kind of questions, they could catch you out by having a return journey as well mentioned. So you would have to calculate that extra distance. But this one, just one journey. So we've got 320 plus 30 times 18. Remember to do the times first because of BODMAS. And that's 540. Then we add that onto the 320 to give us a final answer of 860. Now remember, we've worked that out in pence. So in order to do it in pounds, we need to divide by 100, and that's £8.60. We'd now get 2 marks on that question. We won't get the 3rd mark until we answer the question. Was she overcharged? Yes, she was overcharged. You don't have to write it in a sentence. You can just answer yes, or you could say yes, it should be £8.60. You can put it in an even fuller sentence. The taxi driver overcharged Rachel, but you really don't need to waste time writing really long sentences. Just make sure you answer specifically with a yes or no, and you've got the maths to back up your answer. You couldn't just write yes as your full answer and get 3 marks for that, I'm afraid. It doesn't work like that. So let's carry on, have a look at some more. We've got our friend Pi has come in on this question. It says you can use the pi button on your calculator, or you can use the value 3.14. So when you do your working out, just show which one you've used. So if you use your button on your calculator, just write in the pi symbol. If you're using 3.14, then put those numbers in. It just helps the examiner to know what you've done, and it helps explain any rounding that's happened. So 2 mark question. If you want to pause, we'll carry on afterwards. Now in this question, you didn't actually need to know that around the edge of a roundabout would be classed as circumference, because it just gives you the full formula anyway. So it's a nice question. in terms of there's not really much knowledge you need to have, you just need to fill in the numbers. So you don't need to panic about not knowing much about diameter, pi, circumference. All the information is clearly there for you. So it tells you that circumference is worked out by multiplying pi by d. D is diameter, so if we look in the wording of the question, we can see that diameter is 16. So if we multiply, I'm in this case using 3.14, so I'm going to do 3.14 times 16. If you're using your pi button on your calculator, you'll get a very slightly different answer, but that's not a problem. So you're timesing 3.14 by 16, and you'll get the answer 50.24. I would definitely state my units there because again you don't know when you get those marks. Because we've worked it out in meters, my answer will be in meters. Here's another one. Temperatures, that they do like putting the formula for temperature conversion between Fahrenheit and Celsius. That's very popular on the exam questions. 3 marks again. We're answering, is it correct? Quite a few different methods for this one. So I think we're going to look at a couple of methods, but again, you might do it slightly differently. Don't worry, so long as you're getting the answers right, it doesn't matter if you're doing the order differently or working out in a different way. So if you want to pause and have a go, rejoin me in a moment. So I've decided in this case to work it out to see what the oven should be set at. So I'm not going to worry at the moment that she has set it at 200. I'm going to work out what the oven should be set at. So I'm going to use the value of 350 degrees Fahrenheit and fill that into the formula. So I've written the formula out on the left here, just so I've got it in front of me. And that's telling me that it's 5 multiplied by the temperature in Fahrenheit minus 32, and then all of that divided by 9. So I'm going to fill in that 350 instead of the F. I'm going to do that subtraction because it's in brackets. That gives me 318. The 5 is touching the bracket, so that means multiply the inside of the bracket by 5, which gives us 1590. And then the final step is the division by 9. And that gives us 176. Actually goes on a bit longer on the calculator, so I've used rounding to 2 decimal places. You could do it to a whole number, do it to 1, doesn't matter. I've then compared that. She set the oven at 200. Is that right? So I've said no, the oven should be set, and I've rounded it a bit more at 177 degrees because using my common sense, you can't set an oven to decimal points. So I've just rounded it up there. So that's one way of doing that question and making sure I've put no to get the full 3 marks at the end. So as I said before, this is a good example. This is one we could do in a different way. And I want to show you how you can work questions backwards and also use your skills to rearrange formula. So this next example will show us how to go backwards and rearrange some formula. So it's the exact same question we did before, but we're going to look at it from a different point of view this time. So I'm going to start with the 200 degrees Celsius and work backwards to see if that answer was correct. So the 200 is the C part of the formula. So if you look to the left of the screen here, instead of the C, I'm going to replace that with the 200, but the F is going to stay as an F because we're going to check what temperature in Fahrenheit that actually converts to. Then we're going to compare it to the 350 at the end. So we'll fill that in. Now in this case, we can't really do anything to the right hand side because we can't work anything out at the moment. What we need to do is to find the F part. That's what we're looking for. We can only find a value of a letter when that letter is on its own. So we need to use our rearranging skills to leave the F on its own on the right hand side of that formula and all the other numbers to move to the left hand side. Now, there's different ways of thinking of this. I tend to think of it as always do the opposite calculation to move items from one side to the other. Some people say it is do the same thing to both sides, which they're both exactly the same. It just depends how you actually think of it in your head and how you write it down. Let's see that happening. So here's that formula again. I've not changed anything at the top. The 200's there, the F is there. The first thing I need to move is the 9. You can never move anything from the top of a fraction. You can only ever move the bottom of a fraction. The top is fixed. It can't move until the bottom moves. On the right hand side, we're dividing by 9. So in order to change that, we will multiply by 9 on the left hand side. So it will become 200 times 9. The right hand side will now be just the top part of that fraction, the 5 times the bracket. I'm going to do that 200 times 9, and that will give us 1,800. Now we need to move the 5 part, because the F is what I call trapped inside the brackets. You can't move anything inside a bracket until the things outside of the bracket have moved, or you can move a whole bracket. In this case, because the F is what we want, we're not going to move the whole bracket, we're going to move the 5. We need to remember our algebra rules that the 5 is multiplied by that bracket. So to move it, we do the opposite of multiplying, dividing. So we divide the 1,800 by 5, and that will leave on the other side F minus 32. You'll notice I've taken that part out of the bracket. You can leave the bracket in, it's just not needed anymore. It's not providing a function, so I've taken it out. I'm going to do that division, 1,800 divided by 5, and that's going to give me 360. And on the right hand side, all we're left with now is F minus 32. So our final step is to move the minus 32. Because it's a minus, or it's subtracted, to move it, we add it onto the other side. So 360 plus 32 is 392. That tells us that if the oven is set at 200 degrees Celsius, that's equivalent to 392 degrees Fahrenheit, and we need to say that is not the correct temperature. So again, we need to make sure we answer that question. So in this case, what we've done is to say that if she does set it at 200, that would mean it's the same as 392 degrees Fahrenheit. It should be 350, therefore it's incorrect. Both of the two ways we did it would give us the full marks on that question. It just depends which you think is easier. Now, obviously, I think the way we've just done it was a bit longer, so I would probably have chosen to do it the first way, but there's absolutely no reason why you can't have done it this way. Now, we're going to use that same method of working what I call backwards on the question we did quite near the beginning with the job advert. And some of you may have used this method anyway. So if we remember, she had a budget of £50. I want to know if she could afford an advert with 20 words. So in this case, I'm just going to work with the 50 and not the 20. So it's important that you don't try and work with everything in one go. I'm going to work with the 50. The 50 is the C part of the formula. So instead of the C, I'm going to put 50. And 50 equals 12 plus 1.5 times W. What we need in this case is to see what the words would be. So we need the W part on its own, which means we need to move all the other numbers to the left-hand side of our formula. When we do this, it's always good to think of doing almost a reverse BODMAS. So you start with any addition and subtraction parts and then work backwards from there. So remember before I said the brackets, we wouldn't do the brackets till the end. So it's like a reverse of BODMAS. So I'm going to subtract the 12 first. It's added on the right hand side, so we're going to subtract it when we move it to the left. So 50 minus 12, that gives us 38. The right hand side is now just 1.5 times W, or 1.5 W. Because it's times and we want to move the 1.5, we need to do the opposite calculation of times or multiply, which is divide. So we're going to divide 38 by 1.5 to separate it. I'll do that calculation, which is 25.333. and that tells us the number of words that Pat can afford. So what we can say here is Pat can afford an advert with 25 words. Do need to be careful of rounding here. If that number had come out at 25.7, following normal rounding rules, we'd round to 26. But in this case, she hasn't got enough money to buy a full 26 words, so you would round down to 25 still. So sometimes with these, when you're rounding, you do have to make sure you're following the kind of common sense of the question or the real life situation. And again, make sure you answer, can she afford the advert? Yes, we need to say yes, she can, or she can afford an advert, etc. Here we can say she can afford an advert with 25 words, so she can have some more words if she wants. But we do need to make sure we're answering that question. So that's just another example of how you can do questions in different ways. A bit harder, I think, this question, but don't let it put you off. Have a go. What we're trying to find, a lot of information given here. Just work through it piece by piece. Focus on the information in the box and use the other information to help you work out what you need to do. So this is one where you do need to sort of work things out in a different order. You will need to do some rearranging here. So I'll let you have a go at this one yourselves, and then we'll have a look at the answer in a second. So let's have a go at this one. I've written the formula out in full at the top here because it's a little bit longer, this one. We've got L, and there's quite a few different things here. We've got two different lengths, so we need to get them clear. The first L is length of the lane. Then we've got equals 6.28 times R, which is a radius, plus 2 times T. T is the length of a straight. So we need to make sure we don't mix up lanes and straights here. Fill in what we know and remember to check the units first. So just looking through, I can see meters and meters. Nothing isn't in meters, so we don't need to worry about units. I'm going to fill in all the things I know. We know the L, the length of the lane, and that comes from the line just under the picture. The inside lane must be 400, so we can fill that in. The 6.28 was a fixed value. The R is the radius, so if we look here, it says we use a radius of 38 meters. Put that in, plus 2 times T. T is the length of the straight. That's what we actually need to work out for this question, so we can't put a value in for that. So now we know that it's the T we need to find, and that means we need to get the letter T on its own on the right hand side, and we need to move all those other values to the other side. So before I start moving them, I'm going to see if I can simplify them. Because of BODMAS, we know we need to do any multiplying first. So I'm going to multiply the 6.28 by the 38 first of all. So we'll just double check. Yes, that is 238.64. So just to simplify that, plus still the 2t. We can't do anything with the 2t yet. I'm going to move that 238 over. That's the addition bit. So we're now going backwards in our BODMAS when we're moving things. We're going to move any adding and subtracting first. So we're going to subtract that from the left-hand side. So we're going to do 400 take away 238.64, and that gives us 161.36. So that's now equal to 2t. We need the t on its own, so we need to divide by 2 because the 2 is multiplied by t. We divide by 2 on the left to move the 2 over, or halving the 161, which leaves us with 80.68. So we know the value of t is 80.68. And in this case, I want to put the units on because we don't know if that will be important. We know the length of each straight is 80.68 meters. And it would be fine to round that up to 81 meters as well, because it doesn't mention any kind of rounding there. So you can use rounding rules. So actually, it's not too difficult a question. There's not a lot of maths involved, but it's knowing the order to move the parts around in. Because if you start dividing by 2 as the first step instead of the last step, you won't get the same answers. So you do have to make sure everything happens in the right order. Let's see another question. Quite common, especially at the moment, to have questions around speed and time. And sometimes they're very easy, sometimes they're a little bit more difficult. So I think this one is one of the slightly more straightforward ones. So if you want to pause and have a go at this one, and then we'll have a look at some answers in a second. So let's see what we can fill in. I'm going to check my units again. Kilometres, kilometres, hours, all fine. Fill in what we know. S is speed, which we're given, 600. D is distance, 2,700. T is time, and that's what we're trying to find out. Now this is where a lot of people go wrong because they'll jump in too quickly. When we're rearranging this, we need to get the T on its own, but we can't move the 2,700 first. We need to make sure we get the T on its own, and the T has to move before the 2,700 can move. So the T has to move to the left-hand side, which seems odd because you think you're not leaving it on its own, but you have to do that first. So 600 times T, or 600T, equals 2,700. Then we move the 600 from the left-hand side to the right-hand side. Because it's multiplied by the T on the left, we need to divide by it to move it to the right. Make sure you do this in the right order. 2,700 divided by 600. If you put them the wrong way round, you won't get the right answer. And if we do that division, that leaves us 4.5, nice round number. That is the time, and that's in hours. So it will take 4.5 hours to fly there, or you could state that as 4 hours 30 minutes if you preferred. So that's quite a nice straightforward question around time. Now this next question is a little bit harder. Although it's still a 3-mark question, what we'll notice here is around the units. I won't say too much more. I'll let you have a go at this if you want to first, and then we'll have a look at where the trick is in this question. So if you want to pause and have a go, please do. So the first part of the question actually is fairly straightforward. We can do all the same things we normally do. T is time, D is distance. So we know distance is 14 kilometers. Speed is 40 kilometers. So we can fill in the 14 and the 40. As a division, we can do that division. That gives us 0.35. Brilliant. Now we look at our units, that's hours, so it's going to take 0.35 hours. And this is where we need to focus on our units, because in the question here it talks about 20 minutes. Now where a lot of people get a bit carried away is they forget time isn't decimal. So they say that 0.35 hours is the same as 35 minutes, which of course it isn't. It's about a third of an hour. So if you think about a third of an hour, yeah, it's going to be about 20 minutes, but because in this question 20 minutes is the wording, we can't really guess. If the question said he thinks it will take 40 minutes, we could say no, it will be closer to 20. We could probably estimate. But in this one, we need to be a bit more precise. So we actually need to work out what 0.35 of an hour actually is. Now to do that, this seems slightly counterintuitive. You need to multiply it by 60. If you're not sure, if you're trying to divide it, you'd actually see it wasn't quite right. So sometimes with these, you have a bit of trial and error. If you try one calculation, it doesn't seem right, try a different one. That gives us 21. So we actually know it's 21 minutes. Now, the strange thing for this question is those of you that said Paul is right, were right, and those that said Paul is wrong, were also right. That's because you can say either way here. You can say, yes, Paul is right, and it's about 20 minutes, or you can say Paul is wrong because it's 21 minutes. So either of those answers will give you the full 3 marks, provided you've got the maths to back up what you've just said. And that's another question where you could potentially have started with the time at 20, but you would need to have not put it in as 20, but to put that in as a portion of an hour. So it wouldn't have worked if you just filled it in with the 20 and one of the other numbers. You do have to make sure you're using the correct units. Okay, just wanted to show you what the answer scheme would look like as well. So this is what the proper exam answer sheet looks like. And it gives you a couple of different options on how you could work it out. It talks about doing the division here as well, so working out what the 20 minutes would actually represent and working backwards from that point. So you can work this question backwards. And you've got a few options how to present the answer. You could say no and 21 minutes, or yes and 21 minutes, nearly 20. You could have worked it backwards to work out what the speed would need to be, or what the distance would need to be. So that would be filling in the percentage of the hour for the t and then working out either the d or the s and using the other value. So quite a few options on that one, and you can see lots of different ways to get at those 3 marks. Here's another completely different question. It's a 6-marker, so it's one of the really big questions on the exam. So really important that you're getting as many marks for these as you can, and you're not just skipping past them. It's got lots of bits of information that you're given and bits to fill in. So just take your time to make sure that you're dealing with all of the information. So we'll pause here and then you have a go and see if you can finish it off. Okay, so if we have a look at this one, first thing I'm going to just check is that all my units match, as I always keep telling you to do. So we've got centimetres all the way through, and at the bottom here we've also got centimetres, so no problems with units. I'm now going to fill in all the numbers I know. I know the R, the radius is 80, I know the D is 28, and don't forget to keep the squared in there. Then all we need to do is do that maths on our calculators, so multiply it all out, and that gives us this really big number of 562,688 centimetres cubed of compost. So we've worked it out in centimetres cubed, and that tells us how much compost we actually need. So now we know how much we need, we go back and look at the rest of the question, which I notice I've chopped out here, because you can only deal with one thing at a time. So now I'm going to go on to the bit that talks about the bags and the pricing. Again, you don't have to do it in the same order I did. You can start at this point as we try and work backwards with things. But to me, the other way was the most straightforward. So I've just copied over the amount of compost we need. I think I'm going to look at the number of bags we need first and then decide on the offer that goes with that. Now we're given this extra bit of information under the box that 1 litre is 1,000 centimetres cubed, because of course the bags we're buying are litres and we've worked it out in centimetres cubed. So we need to do a division to turn our centimetres cubed into litres. So we need to divide our big number by 1,000 to turn it into litres, which then gives us 562.668. Now if we look at the bags hold 50 litres each. So we're going to divide our amount in litres that we need into bags. So we're going to put it into bags effectively. So if we divide it by 50, that will tell us how many bags we need. Now I could have rounded that 562 up, but I always think as long as the numbers aren't too big, there's not too many decimal points, it's good to keep it as accurate as possible, because the more you round as you go through, the more likely you are to possibly make a mistake. So I'm going to divide by 50 to split that into bags. That gives us 11.25376. Again, a long number. I didn't need to write all of that out, but just did it for ease, really. Now, this is another question where we need to be careful of rounding rules. With proper rounding rules, we'd round that down to 11. But if Thomas only buys 11 bags, he's not going to have enough compost. So we need to round up to 12 bags here. Now what you need to not do is work with the 11.25, because you can't buy 0.25 of a bag. So you have to work with a whole number from this point onwards. So we've settled on the number of bags. Now we're going to have a look at how to actually pay for those bags. So we need to buy more than 10 bags, 10 or more. We're not buying the 30 or 60 or more, so we can discount those two options. More than 10 bags is 50p cheaper, or saving 50 pence. So the price per bag is £5.69 minus 50 pence, or £5.19. So each of our bags will cost us £5.19. So we multiply that by the 12 bags we need, and that's £62.28. It's always good at this point, I would go back just to the whole question and just look to make sure we haven't missed any key information out. And then we read the question again, how much will it cost him to buy all the bags? We've worked out that money, £62.28, and put the pound sign on. And if you note at the bottom, in the mark scheme, you had to have the pound sign to achieve full marks for this question. So if you'd done all of that difficult working and then not put the pound sign, you'd only get 5 marks. Here's another question we can have a go at. So this one also uses a formula, which is over here with a key, but it also gives you some more information. So it's quite a lot of information here. You've got the bit at the top, you've got this key information here around the total wall area and the total window area. And then you have a table. So as well as your formula knowledge, this is also testing your ability to accurately find information from a table. So it's just a 3-mark question. Have a go at it. Pause now, and then we'll have a look in a moment at how to answer this particular question. So we're going to have a look at the answer to that question now. So we've got the formula, U multiplied by, then brackets, E minus W. So now I'm going to fill in the E and W because they're the easier bits. The total wall area in meters squared, just check those units, yeah, meters squared. So I'm going to put 524.8 in as our E. Our W is the window area, which is 19.12. And filled cavity, so U, if we look here, is a value in watts per meter squared. And it says Ahmed uses the table to find the U value for his walls. We have to look underneath the table to find out that his walls are filled cavity, which means that the number we need to use is 0.45. So this is just a question also testing your ability to read information accurately. So we're going to put that in as the U, and then all we need now is our calculator to do the maths bit. So we're going to do the subtraction first because it's in brackets. Then the 0.45 is touching the bracket, so we times or multiply those numbers, and that gives us our final answer of 227.556. Or I've probably rounded that to 228, just to a nice whole number. Check the question. Is Ahmed correct? He thinks it's 240, so no, Ahmed is wrong. So I've put the heat loss is 228 watts, so Ahmed is wrong. Again, you can put it in your own words. And just to have a look here at the bottom, these are the mark scheme answers. So no, and any value between 227 and 228 was accepted as correct. But what you could also have done is done this one backwards, and some of you may have done that. So started with the 240 as your H, and then work backwards to either find the window area or the wall area of the house. So using one of those, either the E or W, as your missing bit of information. And so you would have worked out that those didn't match. So for example, if you'd worked out the wall area, you would have found it should be 552 if the heat loss is 240. We know it's 524, therefore we also know it's wrong. So that's the kind of way you do it when you work backwards. You need to check your answer you worked out against what's given in the question. So again, lots of ways to do it. Doesn't matter which one you chose. And that's all of the questions that we're going to have a look at on formula. Hope you found those useful. Just a bit of a summary. Always remember to do your calculations in the order of BODMAS or BIDMAS. Remember that idea of not using the multiplication sign. So my tip, when things touch, they times. You might need to rearrange a formula to find the part you want. So that's what we practice doing, rearranging. Always check those units as I've drilled into you by now. If you can, consider if your answers are sensible. Sometimes it's hard to do. For example, on the last question with heat loss, we wouldn't generally, unless you happen to be an expert in that topic, know whether that was a sensible answer or not. But often questions with money, we can see whether they seem sensible. And if a question's really long, just do it one bit of information at a time. Don't get overwhelmed by the whole question. So there we go. That is formula and BODMAS. Good luck with doing those questions. There's usually one of them somewhere on the paper. So and if you look at all the practice ones, you'll probably find a couple of others that you can have a go at to practice with. Good luck.